All right, let's now learn about box plot and outliers. And so before we start, again, let me show you the data sheet here. And we are primarily going to be working on data 1. And there are other data sets on this sheet right here that you can apply the skill here to any other data sets. Okay, so let's look at data 1 here. We have learned from other videos and we have learned through other lectures that data 1 has special location Q1 being 68, Q2 being 74, and Q3 is being 80. So now, it was briefly mentioned in some other videos, but here I'm going to indicate that again. But once we've had Q1 and Q3 here, we can find an interquartile range. And the interquartile range here, simply as a rule, Q3, from where our special location Q3 minus Q1, or in other words, IQR is the total interval range between Q3 and Q1 location. And as a brief reminder, IQR stands for interquartile range. And so right here in our data 1, since we previously found Q1, Q2, and Q3, and the values are here, then our IQR in this problem for data 1 is 80 minus 68, and we're now having a numerical value being 12. So 12 is our IQR. And so now you have seen how to build histograms, and you have been working with some histograms. Then some histogram, if you're looking closely, some histogram comes into a nature like this. It has a focused area where a lot of data are focused in it, and there's an empty area. Seems like completely empty, and then all of a sudden there are a few guys kind of resurface out there. So a lot of time it happens this way, quite commonly enough. It triggers up our curiosity, our attention to it. And so these lonely sitting out there guys right here, statisticians refer to these as the concept of outliers. And so it should be a formal term here, a formal terminology here, that these guys are outliers. So it's not necessary to bring up a worded definition of what outliers truly are, but just think about right here in a histogram like this. For example, like I said, like I described earlier, there's a focused area where a lot of data are focused in, and then things seem to die out, and then there are a few guys, a couple bars resurface. Not too many of them, but a few guys kind of sitting lonely out there. And so that idea is where those guys that we recognize, we call them the outliers. And so at this point, as we already mentioned, then outliers are those data values, a couple of those guys that tend to sit outside of a big main group. And so the question arises now is that how far is far enough to be considered as outliers? And so, and you also must notice that not every data has outliers. So some data set has outliers, some other data sets do not. So here, the trick to determine whether some data have outliers or not depends on we calculating a unique set of LL right here stands for lower limits. Lower limits. And lower limits here is to be, the rule says, from where Q1 that we found previously, we are going to subtract 1.5 times the IQR. So that's the rule to calculate the low limits. And then, if we can have a low limit here, we need to also decide where the upper limit. So UL here is my shorthand writing for upper limits. And as a formula, UL equals from where Q3 of your current data, we are going to add 1.5 times the IQR. So now back to our data 1. Low limits based on the formula can be found by where our Q1 was 68. We are going to subtract 1.5 times the IQR we found previously being 12. And so now a calculation shows that this is 68 minus this multiplication here is going to turn me into an 18. So 68 minus 18, we ended up with a lower limit being 50. So I'm not too worried about explaining exactly what the low limits are doing, the low limits or the upper limits are doing to your data yet, but we will get there. For now, it's strictly I'm following with the calculation formula that was given out previously. And so my low limit of this data 1 is 50. Similarly, my upper limit, the rule set from where Q3 currently is, we're going to add 1.5 times of the IQR. And so Q3 is being 80. I am going to add 1.5 times IQR we found being 12. And so calculating it, I'm looking at 80 plus this product of 1.5 and 12 gives me 18. So my upper limit is 98. So in other words, now I say that my data 1 has low limits being 50 and up limits being 98. But so what are these low limits and up limits? What are they doing to the data set? Remember that our major goal right now is to find outliers. And I did mention earlier that how far enough is to decide who an outlier is, or how far enough to decide, within which boundary to have outliers. And so now here I'm telling everybody, outliers in your data 1, to find outliers, all you have to do is to imagine that you have a set of low limits from 50 and the high limit is 98. So any data values that being contained inside. So low limit is sort of like a left fence right here, being 50. And high limit is 98, upper limit is 98. So values being in here are just the usual, the common values. So common value, nothing special, stays according to this method of finding outliers. Then all those are data values being inside of this limit we found. They are the common values. And so now outliers will be whoever falling outside of these two limits. And so if you're looking at your data 1 a little more closely, then we did recognize there's 104 as a value being above 98 outside of the limits. And 124 is also another candidate that fell outside of this limit. and these are our outliers on the upper side. Now be cautious that anytime you're looking for outliers, there can also be outliers from the low side of your data. Sometimes it happens, sometimes it doesn't, sometimes both way happens. So you must also double check. However, your data 1 here, the lowest, that's why knowing the minimum and maximum is always helpful. Minimum value of our data 1, to remind everybody, is 60, and it's being completely contained inside of your limit. And so now, concluding our final answers, outliers of data 1 is that set being those two numbers, 104 and 124. So those are the outliers. And so now for box plots, it's another graphical display of numerical data, but sadly I couldn't show anyone this box plot method any earlier unless you have learned and found out in your data a Q1, Q2, and Q3. So box plot here, anytime you're about to construct it, you definitely need to have Q1, Q2, and Q3 of your current data found. And so let's say we're going to construct a box plot in our data 1. So data 1 as a reminder for everybody. And you can quickly have a look at data 1 here. So data 1 has Q1 we found being 68. And again, Q2 is being 74. And Q3 being 88. I'm sorry, 80. And so now here's what I'm doing with my box plot right here. In my way of constructing this box plot, on this line of numbers right here, then it really doesn't matter at start where you put down, you can just simply put down 2 spots right here. And these 2 spots, however far between them, it's also pretty much your choice. But now I'm going to call this spot right here, this first spot on the left is Q1, and the other spot on the right, I'm going to call it Q3. And so now once you actually put down and label these, that actually defines the rest of your scale right here. But so now at least for data 1 here that I'm working with, then that space between Q1 and Q3 is going to be, well, and numerically speaking, Q1 is 68, Q3 is, and so if you're starting to realize that distance between Q1 and Q3 is being 12 numerically, which happens to be our IQR in between. But you don't have to find the IQR beforehand. You don't need to find the IQR only to be able to build a box plot. That's what my point is. That's why when I first put down the Q1 and Q3, I'm not too worried about how far spacing apart. And so now the whole idea now is that the plot we're about to construct here is called a box plot. So where's the box? The box here is right through your 2 values, Q1, Q3, that you put down previously. So I'm going to put solid line and to create a box. So the box starts at Q1 and ends at Q3. And so now, so it makes sense at this point that your Q2 value should be somewhere inside of this box. Now be careful with the way how I'm saying it. All I'm saying is Q2 has to be somewhere inside of this box. Somewhere inside of this box right here. It doesn't necessarily have to be right in the middle. Some data, it could be a little closer to the right hand side. Some other data, it could be a little closer to the left hand side. It's just our data set 1 happened to have Q2 exactly in the middle. And once again, we're going to draw a vertical solid line right in the middle of the box. It's called that Q2 is right in there. So how do I know? We can quickly check, but numerically, that space between Q1, Q2, and Q3. We are doing a quick math right here. 80 is Q3 minus 74. That gives me a distance being 6. That's from Q2 to Q3. You can do a 74, which is Q2, minus 68. That also gives me a 6. That's why my Q2 in this picture convinced me that it should be exactly in the middle. And so now the next details we want to put into your data 1 here is that now remember the lower limits and the upper limits that we've learned. The lower limits that we used just earlier to find our outliers of data, the value for that, the upper limits for that was 98. So we don't always have to put this down into the box plot, but in case you need to put it down, then here's how you can put it down. Now 98 makes sense to stay to the right hand side of this box somewhere, but is it here or is it there? Here I would say a little too close. Here I would say a little too far. So how do I know to be precise? Now we don't need to be as precise as how a computer is. However, there's a certain ways how you can check for your own consistency right here, and that's why it's extremely important that once you define your own box length right here, which is as long as the IQR, then I am going to fix my box length. And from where my box length is, I'm going to maintain the exact same box length. I'm going to go one more box to the right hand side. And I'm going to, from where that is, I'm going to go another half box, so which is about right here. So my upper limits, not really part of the data. So that's why I'm putting that as dotted lines right there. But the upper limits being value at 98 is here. In case you have to put it in. And like I said, the reason these are dotted lines here is because some box plot does not require you to put down the upper limits and the lower limits. So if you want to put down lower limits as well on your data, so here's what it's same idea of how I found it. I'm gonna go from one box length from the Q1. I'm gonna go to the left one box length, one additional box length to the left from where Q1 is. And I'm going to go about another half. That is where I'm having about a consistent lower limit right there. And value is 50. And so now, and we can now erase this away. You have a sense that minimum value is being contained inside the two limits here. And so in that way, my minimum is somewhere here, and it's part of the data, and it's a requirements element. We're going to put the label there, minimum, and the actual numerical value being 60. But maximum is outside of the limits, and here we can start going a little loosely here. But we can draw maximum is kind of out here. Okay, another solid line, maximum value being 124. And then now the next thing we want to do here is we are going to draw a set of arrows pointing from the box, going through the limits and stops, point right to the maximum. So remember, the arrow comes out from the box, not going through the box though. Comes out from the box and point to the maximum and stops right there at the maximum. And I'm going to draw another arrow from the box pointing to the minimum and then stops right at the minimum. But that's how I complete my box plot. And at this point right here, let's understand a couple further details right here. Now, things number one to take note about. The box plot is not required as a way to find outliers, because we already found a method to find outliers. In this box plot right here, see, to check for consistency with what we have done earlier in terms of finding outliers, your low limit is here, your up limit is here. So the arrow here is indicating that maximum stays, we got some values, at least the maximum value in the data stays outside of the up limits. So indicating at least we don't, in case we don't have to name all outliers, then we know that in this zone right here somewhere we have some outliers. And then the low end, the low end of your data 1 right here of your data is completely contained inside the low limits graphically. And so quickly looking at a histogram without looking into all the details of the numbers, then you can still tell that there are no outliers in the low side. All right, then now let's look at, so we have built a box plot as an example right out from our data 1, and we discussed a couple details directly related to the box plot and also how it's consistent with other details in data 1. But now, generally speaking, what's so useful about a box plot out there? So we already found a numerical way to find outliers. We found a numerical ways we can bypass the box plot, and we can still come up with low limits being Q1 minus 1.5 times the IQR, and that's how we come up with the low limits. And then we can just numerically calculate our up limits here by going from where Q3 is of the data plus 1.5 times of the IQR, and we are just fine on our way to, once we come up with the lower limits and the upper limits, naming out the outliers are just fine. We don't need a box plot for naming the outliers. However, there would be time where your data is being given. So think about the whole reason that we can calculate outliers based on calculating the lower limits and the upper limits here is simply because we had our data given as a list, and we saw the list. What I'm about to say now is that there could be time, what if the data, instead of given out as a list of data like you usually see in your data sheet, instead of that, what if your data is given as a box plot? The box plot here is saying, hey, on your line of numbers here, in your data, we got a box like this. And of course, so rule of thumb, starting point of your box is Q1, ending of the box is Q3, and somewhere in here is Q2. And I don't even need to worry about the numbers and the numerical labels on these. But so, and we have another solid vertical lines to the right of your box. So remember from the example we did, this must be the maximum, even though there was no numerical label. And then the arrow points out to it. And then there's another solid line, vertical solid line out here, and then another arrow pointing out to that line. So learning from our examples, then we know that this must be the minimum. And so sometimes you can have a data given very abstract, a data given abstractly as through a box plot. So the question being brought up now about this box plot, and keep in mind we completely clueless about the numbers. We don't have the list of numbers. We know that there's a data here being represented by the box plot here, but we just completely do not have any numbers to work with. And so the question now is, can we decide if there are any outliers? And notice the way how the question is being asked. The question is not asking us to name who the outliers are. It's only asking us to predict, to decide whether we can have any outliers right out from this. It's sort of like a way of quickly judge whether we can have outliers or not without the need to name who the outliers are. And so in this way, here's how I can find it. Here's how I can make my judge right here. So from what I'm looking at this box plot right here, this is what I'm doing. I am going to try to maintain the fixed distance between Q1 and Q3. And then once I'm holding to that space right here, then I'm going to go one more box from Q3. And then another half box from where Q3 is. And I'm going to put down a dotted line right here. But now remember what that was? This is actually my up limit. All right. And then the same trick I'm doing here. One box length, I'm going to try to fix that box length right here. I am going to go from where my Q1 is. I am going to go one box to the left from where Q1 is. And another additional half box about there. And I'm going to put dotted lines there again. This is lower limit. And so now once I put down up limits and low limits, and of course I don't need to be exactly precise and exactly on scale right here. But what caught my attention now, what tells me right through the eyes now, is that the minimum of the data and the maximum of the data, in this case, the way how the box plot was given, minimum and maximum, these two values are being completely contained inside the two limits, lower limits and the upper limits. And so that means a data like this, the answer to the questions, decide if there are any outliers, we are going to say no, because the maximum and minimum values are completely contained inside the limits. And here's another quick example to explain how useful a box plot can be. And believe me, statistics that you're learning is all about how creative you are in terms of using all these tools. So my examples are not the only examples that exist out there. It all depends on different career, different kinds of work path that you are doing that takes you into different creativity, takes you into different ways how you can creatively use your box plot right here. But so let's say you have a data again, and once again there are no list of data. You don't see the list. All you see here is a box plot. So a data given to you, and you have a rule of thumb now is beginning of your box plot is Q1 and ending of your box plot is Q3. This is the line of numbers, and your box plot is looking like this. Maximum is here. Quite a long interval. Quite a long distance. And like I said, we don't always have to put down up limits and low limits unless we need to use the box plot to detect some possible existence of outliers. But here I'm having a box plot, and Q1 is here, Q3 is here, and my minimum value is here. Okay, and I'm not even worried about the numerical values because, like I said, we don't even have a list of data listed here. So, and Q2 is somewhere inside of this box. And once again, we're using the solid line for Q2, Q1, and Q3. But now what does this box plot tell you in terms of data focus? What can you say about data focus or data fading area in terms of simply by looking at a box plot like this? Now remember, Q1, we've learned in some other lecture or in some other videos that Q1 is the 25th percentile. Or in other words, it means, practically speaking, it means there are 25% of data being below Q1. And then likewise, now don't get yourself confused with the fact that the length of the interval is pretty short. It's not the point. The point is I'm talking about the amount of data being to the left. And so now I can see that there are 25% of data being in that interval between the minimum, anywhere from the minimum to the Q1 value. That's your first 25, the first quarter of data being below that Q1. And so now the length of your box plot naming is the IQR, interquartile range. But now how much data is being contained inside of that short box? A short box, you can see that the interval's length is only about the same in my picture right here. The interval's length is only about the same as that length from the minimum to Q1. But in such a short interval like that, it contains up to 50% of data. And so now you can see that from the minimum up to Q3, it's already covered 75% of your data. And then in such a lengthy interval, all the way from Q3 to maximum, the reason it's lengthy, it could be because you have a high value here, but your Q3 is only somewhere low value. But a lengthy interval like that only contains another 25% of data. And so now that here tells me that in this data right here, more data focus, more higher amount of data focused to the lower side of the values. So it's a data like this, a box plot like this would likely to represent a skewed, more like a skewed right distribution if you really have to put up a histogram sometimes.